Motors are everywhere. They power our world. Motors turn electrical energy into motion. Think about your blender. You flip a switch and the blades spin. That's a motor at work. There are many types of motors. Two common ones are brushed DC motors and BLDC motors. BLDC stands for brushless DC. They both use direct current power, however they have key differences. These differences impact their performance. They also impact how long they last. Understanding these differences helps you choose the right motor for a job. Imagine you need a motor for an electric car. You would want a motor that's powerful and efficient. You would likely choose a BLDC motor, but for a simple toy car, a brushed DC motor might be perfect. One big difference is how they switch the direction of current. This switching is called commutation. Brushed DC motors use brushes. Brushes are small conductive blocks. They rub against a rotating part called a commutator. The commutator has segments. As it spins, the brushes contact different segments. This contact creates a change in the magnetic field. The change in the magnetic field makes the motor's rotor spin. BLDC motors don't have brushes. They use electronic commutation. Electronic commutation uses a circuit board to switch the current. This circuit board is called a controller. The controller senses the rotor's position. It then energizes the correct coils in the stator to keep the rotor spinning. This brushless design makes BLDC motors more efficient. They lose less energy to friction. Brushed DC motors are simpler. They have a rotor, a stator, and brushes. The rotor is the spinning part, the stator is the stationary part. The rotor has windings of wire. These windings carry the current. The stator creates a magnetic field. This field interacts with the rotor's field. This interaction creates torque. Torque is a turning force. BLDC motors are more complex. They use permanent magnets on the rotor. They also have more complex windings in the stator. This design makes them more powerful for their size. BLDC motors are also quieter. There's no brush friction. This lack of friction makes them ideal for applications where noise is a concern. Brushed DC motors are great for simple tasks. Think about toys, fans, and windshield wipers. They are inexpensive to produce. BLDC motors are better for high-performance applications. These applications include electric vehicles, drones, and power tools. They offer more power, efficiency, and lifespan. However, BLDC motors are more expensive. Their controllers add to the cost. So which motor is better? It depends. It depends on your needs and budget. If you need a simple, low-cost motor, a brushed DC motor will do, but for high performance and efficiency, go for a BLDC motor. You'll be glad you did.